Dear students, we shall start a new chapter, alternating currents. The previous all the chapters we had seen about battery connected to resistor, capacitor, inductor. But here the alternating currents means not only currents, we also see the voltages. Alternating means changing with time, changing with time. What are changing with time? Here voltage voltage and current are changing with time. Voltage and currents are changing with time. Voltage and currents are changing with time. What about direct current? This is called as direct current, which is equivalent to battery, right? This is voltage, which is called fixed voltage when you take the battery and does not change with time. This is does not change with time. What is the frequency? When it is not altering with the time, the frequency obviously which is equal to 0. This is symbol with simple dashed lines means no frequency, no altering values, right? Here now, what is alternating voltage and how it is written? In the last chapter we derived the voltage which we developed or EMF developed across AC generator. What is the value of voltage which was developed in the AC generator? E is equal to E max sine omega t, or which is equal to E max N B A omega sine omega t, which was derived. So this is called as E max, E max value. And we simply we write here, this is written as voltage V is equal to V max sine omega t. V is equal to V max sine omega t. Entire the chapter we substitute or we apply the voltage V is equal to Vm sine omega t. The symbol which is the alternating current symbol, which is E, written as this one slanting. Yes, this is applied means AC voltage applied. This is the meaning of AC voltage applied. Now, what is the graph? How to write? Now it is altered. See, this is the time voltage graph we observe it. Time voltage graph. This is 0. When time t is equal to 0, sine value which is also equal to 0. You know very well that omega t which is equivalent to theta. Sine 0, 0. Now we shall start from here. This is 0. And omega t or sine 90, 1. V is equal to V max. So this is called as V max value. Next, add one more 90 degrees, V90. What is this? This is called again sine 180, 0. And add one more 90. This is called, you will get it as value minus V max. What is this number? This is equal to V minus V max. And again 270 plus 90, 360. And this is the value. So what is the time which is equivalent to time period? What is the corresponding equivalent angle? Angle which is equal to 2 pi radians or 360 degrees. So equivalent to 90 degrees, which is the path which is equal to this one. Next to 90 degrees, this is a path. Next to 90, this is the path. Next to 90, this is the path actually. So the average value over one cycle, which is equal to 0, upward positive, downward negative. So average value over one cycle average value of voltage over one cycle, which is equal to 0. Otherwise you write it like this: the average value over the one cycle 0 to t, and this is a sine, right? Sine omega t dt by 1 by t. If you calculate it, this is the 0. So this is called as average value of over one cycle. Similar fashion, if you write it, I is equal to Im sine omega t graph, means I is also changing with the time. When voltage is changing, current is also changing. So this is now I and time t. And how do you write them? Just sine, again sine 0 0, sine 91, sine 180 0, times 270 minus 1, 360 0, like this, 90, 180, 270, like this. Same pattern that was observed as in voltage graph. This is equivalent to one time period. What are the major advantages of this AC? AC advantages are they travel long distance without losing energy, and these voltages are stepped down. Stepped up means voltage can be decreased, voltage can be increased using transformer, and there are certain advantages over the DC. So in the household, generally in our homes, we use AC power only, AC voltage. Generally, if you observe this voltage, if you connect voltmeter, you will get 220 volts. That is VRMS. RMS voltage, you will get it as 220 volts. This is a general introduction part. Now, what we do? This AC can be connected to across resistor separately, inductor separately, capacitor separately. Later case, we take it as series connection and we observe that what is happening with the voltage and current, and what is the phase difference between voltage and current, who is maximum at same time and who is minimum at the same time. Compare the I and current and voltage values. See, this is now, let us understand simply, AC across the resistor, AC across the resistor. Then, how to connect this AC across the resistor? This is the resistor of R certain value, and we apply, what is that? AC voltage we applied. AC voltage applied. AC voltage V is equal to sinusoidal voltage V sine omega t we applied. You know very well, while studying the Kirchhoff voltage rule, current rule, and when along the direction of the current, the voltage drop across resistor is taken as negative, minus IR. Generally, we will take it as along the direction of the current. This is the drop is taken as minus IR. Now we will apply this Kirchhoff voltage rule. Kirchhoff voltage rule. Kirchhoff voltage rule. What is this Kirchhoff voltage rule? So along the loop, the voltages across all the elements are 0. Sum is 0. Now Vm sine omega t minus IR is equal to 0. So I is equal to Vm by R sine omega t. Vm sine omega t. This is actually, we got it as equation 1, we write it. And what is the I? According to Ohm's law, V is equal to IR, and if you want to get V max, you will get it as I max R. Do not write R max, R is fixed, we have already taken it. So how do you write them? V max by R, which is equal to I max. So I is equal to I max sine omega t. So we got it as this current value as we applied voltage. Now what is our observation? That current is also sinusoidally varying with time, right? This is what actually a voltage and current. Now we shall combine the two graphs as we obtain, and I'll choose time on the x-axis voltage on the y-axis and sine 0 started, and this is the called as sine curve voltage. This is called Vmax, and this is called as minus Vmax, right? And with red color I'll draw current on the same graph. I starts from 0, and this is called Imax, and this is, what is your observation? The moment both are 0, the moment they both are 0 at the same time, but this is a maximum Vmax, and this is called as Imax. So the Vmax and Imax are obtaining the same time. Means what is happening? Both are occurring the maximum values, minimum values at the same time. Means that they are in phase. No phase difference. So here voltage and current, voltage and current are in the same phase. Voltage and current is in the same phase, no phase difference. Okay. Now, how to this represented as with phasor diagram? Let us choose this phasor diagram, because next inductor and capacitor circuit we prefer phasor diagram. We explain the phase. See, let us choose first V. This is the V, and making omega t angle x axis. Then what happens? This is the V, and this is called as Vm cos omega t, and vertical projection on the y axis, and the y axis, this is called Vm sin omega t. As omega t is changed, theta value changed, the projection value which is also changed, means Vm sin omega t changed, right? This is x component, this is y component, you know very well, you studied the vector components. See, this is called phasor, which is rotating about the origin. Obviously the vertical projection changes. Now see this I we also got it same, right? And this is what the projection, vertical projection on the x-axis, and the y-axis projection I is equal to Im sine omega t. See that both are aligning in the same way and rotating about this one. Obviously the projections are same, and both are observed to be in the same phase. Generally we explain with the phase with a phasor diagram. Now, what is the power? Power is equal to V into I. Power which is equal to Vm sine omega t and Im sine omega t. So, power which is equal to Vm Im sine square omega t. Now, I would like to calculate the value of average over one cycle, which is equal to Vm Im average sine square omega t. What is the average value of sine square omega t? If this is 1 by 2, because if you want to calculate this average value of this one, 1 by t integration 0 to t sine square omega t dt, you will get it as of, if you want to do, you can do that. So the power over one cycle, which is equal to half into V max and I max. So generally the average value over one cycle of the voltage is 0. Average value of current over one cycle is 0. The average value of power over one cycle is not 0. This is generally a question they may ask. Why it is not 0? Means power is a multiplication, and we got it as sine square theta, right? Average value of sine square theta is not 0 for one cycle, right? And I also write this in the way which is equal to Vm by root 2 and Im by root 2, right? 2 can be written as root 2 into root 2. So we write it as the term which is equal to Vrms and Irms. What is RMS? Roots means square voltage and root means square current, Irms. Generally, at our homes, when you want to measure the voltage, that voltage is called RMS voltage, root mean square voltage. This is equivalent to power which was drawn in the DC circuit also. Whatever the formulas that are chosen in the DC analysis, the same formulas are applied here. So this is the value Vrms into Irms or V into I, which is equivalent to DC circuit that we had seen in the previous chapters also. So power across average power across one cycle over one cycle is not zero in the resistor circuit, but this would be different in the inductor and capacitor circuits that we would see in the later.